Hey yo, what's up? YouTube, it's your boy, a J, a O, a S, a H, a B, R, A, H, A, M. We're back with the, what is it? We're back with the, what is it? I'm having my sequence analysis class in about 30 minutes or 1 hour, and before that, we're gonna look into we're gonna review what I did because a lot of shit I did was based on AI and I don't know too much. I agree, people. I am stupid. I know. I'm not the intelligent one. But yeah, normal people gotta learn. Normal people gotta learn. It's not the world ain't for the smartest or anything. Come on. So I have my class based on this assignment, the last one, in about 30 minutes, and I might be asked to do a presentation on this. So let me know what are the things I did to get the data I produced, and how can I interpret slash change the variables I'm looking for is more accurate. Kesoi, yo, what's up? Hey yo, what's up, gang? How you doing? It's been a while. It's been a while. It's my chat. It's my what's it called? Description showing restream. If it is, I gotta change it. What's up, Kesoi? How you doing? I'm here to look into the presentation, the assignment that I submitted. So yes, they look into the assignment that I submitted because I'm gonna be having a class in about 30 minutes, and they might ask me, "Yo, Mr. Abraham, what is this? What is that?" And I'd be like, I fine, man. I fine, man. Okay, what up to? It's been a while. Yes, indeed, it's been a while. Yes, so I was, yeah, like I said, I was looking into these models. Hope you're winning your battles. Oh, I gotta tell you, one really good thing happened. So there's a subject called Introduction to General Chemistry, and I failed that exam 4 times. And the last exam, the fifth trial was 9th of January. Yeah, 9th of January. And if I failed that fifth try, I would get study ban. It's not like study ban for a period, like, oh, you don't get to attend this subject for 6 months. No, I can never attend that subject or courses related to that subject on this university. I was like, damn. God damn, that's not good. But we passed the exam. Oh, oh, oh. That was a good news, I gotta say. And there's the next one. I should be looking into this much earlier, but my lazy ass is not taking things serious. Let's go, big W's. Wait. W's in the chat. W's in the chat. Let's fucking go. Oh yeah, but we still got a long way to go. I gotta find a job. This month I did not pay my rent. That's not good. And my credit cards are bleeding. They are bleeding. So yeah, well, we got a long way to go. What's the problem this exercise solves? You were given short DNA fragments. You were given short DNA fragments from the virus. The goal was to decide which virus each fragment comes from using a penetrated biological language model instead of hand-designed features. www, yes. That was good. Okay, so you got some W's. How is? Yo, you will find it, man. I will. That's what's all about, right? Man, after I get the job, I could play some video games. You know what I'm saying? I could get back into Lysope. What was the other game I bought? I bought an old game, but I'm a big fan of the game. Oh, what's it? Sleeping Dogs. But not right now. Right now we gotta focus. The goal is to decide which virus each fragment comes from using a pre-trained biological language model instead of hand-designed features. These mimics real nanopore sequencing. You get a pieces of DNA, not full genomes. What the NT transformer does, the nucleotide transformer is like BERT for DNA. I don't know what BERT is. Looking forward to them games. Yes. And I apologize for the latency. It's like 20 minutes difference, right? I was studying right now. No way. Well, don't get me wrong. What are you studying? Saw you online though. Would just say hi. Gotta get back on study. That's the right thing. Gotta stay focused. Gang, stay focused. It was trained on millions of DNA sequences to learn codon structure, motifs, regulatory patterns, evolutionary signals. When you feed it the DNA sequence, it converts into 1280. Yes, Pisces. Peace. Appreciate for checking out the stream. When you feed it a DNA sequence, it converts into a 1280 dimensional vector that summarizes the biological meaning of that sequence. Now, I need to know what this dimensional vector. Can I get the physical representation of that? Okay, can I get physical representation or explanation on that? Because when I hear vector, my mind is going for a force with a direction. Physics vector. Vector is this vector is called embedding. turned okay. So basically it turned 500 and this vector turned 512 BP DNA sequence to 1280 vectors numbers. What you did step by step? Each sequence already had a virus label: COVID, MERS, SARS, dengue, hepatitis, influenza. Not gonna lie, I gotta open the pie chart. Oh, come on now. What? What? We got 22, 21. Yeah. K-Soy, I'm guessing you're not in the chat. I'm gonna refresh the chat because, you know, this side of the screen. OBS crashed? No. Where's the chat? What happened to the chat? What? Okay, chat is back. Oh no, I did not see that. Okay, so that's what it is. Each sequence already has a virus label. Embed DNA with NT-transformer, DNA, NT-transformer, 1280 dim vectors. You did this for 1320 sequences and saved. This separates biology model from machine learning. Linear probing. You froze the transformer and trained a simple linear classifier on top. Those terms are not looking good. You froze the transformer and trained a simple linear classifier on top. Are these embeddings biologically meaningful? If a simple linear boundary was set can separate virus types, the embeddings contain strong biological signals. You trained the logistic regression on. You got the necro. This means the viruses are perfectly separable in embedding space. This is actually expected on this dataset. These virus families are genetically very distinct. Yeah, accuracy 1 is not. That's not trustable. Embeddings and projected them into a 2D using TSNE. TSNE preserves local neighborhood structures, meaning if two sequences are close in a plot, they are similar in DNA sequence. If two sequences are close in a plot, they are similar in DNA space. If two sequences are close in a plot. Okay, you produced TSNE virus embedding. These color cluster corresponds to one virus family. This visual proof that the model learned biological meaningful structures. What your outputs mean. Each row equals one DNA sequence. Each column equals learned biological feature. That is your feature matrix.
the virus ID for each embedding. This is your ground truth. TSNE virus embeddings.png shows COVID sequence cluster together, dengue sequence cluster together. This means CNT transformer has learned viral taxonomy from the raw DNA. Why accuracy is 1 is not a red flag here. You tested on training data. This answer is the embedding linearly separable. Will this... A lot of terms. I don't get it. You cap DNA at 512 seq base pair. Shorter, faster, less biological context. Longer, more context, more memory, better classification. This controls signal versus noise. Which NT layer you use? Right now you use the final layer. Lower layer, learn raw sequence patterns. Higher layers, biological meaning. Sometimes middle layers works better for classification. Linear probe was fine tuning. You used linear probing. Transformer frozen. Only classifier trained. You could do full fine tuning. Train the transformers on virus data. Watch much better performance. Needs GPU and more time. TSNE parameters 30. Perplexity 30. Lower, tighter local clusters, more global structures. This changes how clusters look. And after reading the explanation you gave me, I have a lot of doubts, mainly because I don't know most of these terms means. There was a sentence, where is it? Breakdown. I didn't get this. I did not get this sentence, and sentences like these are one bit. This confusion is exactly where real understanding starts. Oh, shut the fuck up. I will translate everything into plain physics styles intuition. What a 1280 dimensional vector actually is. Forget physics vectors for a moment. In machine learning, a vector just means a list of numbers that describe something. Okay. If I describe a person, it is a three-dimensional vector. Ah. Each number measures some learned DNA property. The neural network invented it, but it's consistent across all sequences. That vector is a coordinate in biological feature space. What space is this? Imagine a map. In biology, the NT transformer invented 1280 coordinates like GC patterns, content patterns, codon usage, viral motifs, mutation signatures, evolutionary. You don't name them. The network learned them automatically. Each DNA sequence becomes a point in this 1280D space. Okay, so if I want to know, if I want to know what the numbers to which codons or codon pairs
Codon.
What freezing the transformer means? You have two parts. NT transformer, this turns DNA to numbers. This turns numbers to virus name. So if I want to know what numbers were given to which codons or codon pair.
This turns numbers to virus names.
Is okay, I get the freeze part. Like using a microscope. You don't change the microscope, you just analyze what it shows. Okay. Only the classifier is trained. What linear classifier means? So linear classifier is the simplest possible decision rule. It draws a straight line. It draws a hyperplane. It answers which side of this plane is this DNA on? If virus families are separated by a straight boundary, it means the embeddings are very good. You used logistic regression, which is exactly this. Can I search for a logistic regression?
Mm-hmm.
What is this? Uh, Okay, so that's linear regression. Oh, logistic regression. What linear probing means? Linear probing. Test how good the embeddings are by seeing if a simple linear model can classify them. You're asking, did the NT transformer already organizing DNA into virus cluster? Your accuracy is one. That means in embedding space, COVID are completely separate regions. That is extremely strong biological signal. What TSNE does, you cannot see 1280 dimensions. TSNE squeezes them into 2D, keeping neighbors together. So your plot shows. I cannot imagine this 1280 dimension. But that's where the math happens. Dots close together in genetically similar color, virus type, cluster, virus families. This is a visual proof of classifier saw what you really built. Raw DNA, biological language model, numerical biology, machine learning, virus identity. This is exactly how modern virus detection works. If you want, I can explain why 512 base pair. I think I know why 512 base pairs. Uh, I cannot. I don't. I don't understand this 1280 dimensions. Mm, 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 mm. No, no, I got 10 minutes. Oh, no, it's not good. It's not looking good. Whoa, 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 whoa. Again, I'm getting distracted. That's so bad. I should set a timer for 10 minutes. The core conceptual wall. Once this clicks, oh shut. You will never get a table like codon number That does not exist here. Codon, feature 127. This is not how transformers work. They are coordinates of the whole sequence in a learned biological space. What? Could you could you explain more on this learn space? I'm still having a hard time. This also, I'm a beginner to this whole thing. What 1280 dimensions really mean? Imagine you want to describe a face. You could use eye distance, nose width, jaw shape, skin tone. That's maybe 10 numbers. Now imagine a super AI uses 1280 measurements you don't understand. Why would you say that? Why would you say I that you don't understand? Bro, I'm the one who's using this. The fuck you mean? Each face becomes. Oh, bro, Kanye, shut the fuck up.
Pick a pom pom pom, pick a pom.
DNA works the same. Each of the 1280 dimensions has some patterns in the DNA that helps distinguish biological meaning. Distinguish biological meaning. I need to know what is it. If I don't know what means, are you separating the data or converting the data or bottlenecking the data? I need to know what methods you chose. What are you talking? But it's not human readable. Stop saying that. There's nothing a human can read. Shut up. Why you cannot interpret dimension 347? How did it get to 347 now? How often ATG occurs near a mutation hotspot in RNA virus compared to DNA virus? You could not name even if you tried. The model learned it by looking at billions of nucleotides. So is a learned axis of biological variation. A learned axis of biological variation. I'm starting to understand that the so is there a hierarchy order? Not. What happens inside the NT transformer? The transformer reads the sequence token by token. At every position, it builds an internal vector that depends on the codon, neighboring codon, long-range structure, evolutionary pattern. Then it averages all the positions to get one vector for the sequence. Wow, what did I just read? At every position, it builds an internal vector that depends on the codon, neighboring codons, long-range structure, evolutionary patterns. It builds an internal vector that depends on the codon. Then it averages all positions to get one vector for the sequence. Averages all positions to get one vector for the sequence. Then it averages all the position to get one vector. Then it averages all the position to get one vector. So your final 1280 vector is a summary of everything the model saw in the DNA fragment. Why? This is insanely powerful. Two DNA fragments that come from the same virus have different mutations, will still end up near each other in D space. That means the space encodes biological similarities, not literal letters. Ow. Why your linear classifier hits 100% accuracy? A space and biological similarity. When you saw clusters in TSNE plot, that was virus families occupy different region at the 1280D embedding space. TSNE just flattened it into a 2D so you can see it. Again, I cannot visualize this 1280 dimensions. Like we got the x-axis, we got the y-axis, we got the z-axis. How do you get how can you get more than that? Again, also the 2D part, flatten it to 2D. Which part, which axis are we kind of sacrificing for that 2D image? Here, which axis are we sacrificing slash combining to get the 2D image? Because in this type of dimensional plotting that's converted to 2D mini overlappings could occur just because one of the coordinate they have they share. Final reality check. You did not map codons to number. You built something more powerful. A machine learned coordinate system for biology. Uh, Machine learned coordinate system for biology. Every DNA sequence becomes a point in this invisible biological space. Viruses are clustered, bacteria are elsewhere, human DNA is elsewhere. That is modern computational genomics. Stop saying bullshit, bro. I don't get it. It's just maybe I'm too stupid, but why averaging tokens? Why 512 base pairs? How this detects unknown virus? What is learned biological space? Forget biology for 30 seconds. Let's reset a timer for 10 minutes. A city is represented by two numbers, latitude and longitude. Those numbers mean nothing by themselves, but they become meaningful because nearby cities have similar numbers. Now replace cities with DNA sequences. The NT transformer invents a coordinate system where sequences from the same viruses are close. Sequences from different viruses are far apart. That coordinate system is the learned biological space. It's not physical, it's not chemistry, it is a mathematical space that captures biological similarity. How does the model create this space? The model was trained on billions of DNA bases. During training, it learned which DNA patterns tend to occur in the same organisms. Over time, it learned to arrange sequences so that COVID like sequences are close, dengue like sequences are far, bacterial DNA is far, human DNA is far. It does this without labels. It learns structure from raw sequences. I don't know how. I learned how. So every new sequence is projected into space as a point. That one two vectors, that is a coordinate. These are the coordinates of sequences in biological spaces because biology is insanely complex. If you try to describe DNA using GC, blah, 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 you need hundreds and thousands of numbers. The model discovered 1280 useful axes automatically. Each axis is a pattern that helps distinguish. Again, how do you put these axes? Like, are all these axes perpendicular to each other? It cannot be perpendicular to each other. Or can it? Technically, it should. Yeah, technically, it should be perpendicular to each other. If we are making axes perpendicular to each other, we could get 3. Okay, for each axis, we could get 3. No. 1, 2, 3, 4, 5. 5 axes, okay. No. 4 axes, okay. Okay. The model discovered useful axes automatically. Each axis is a pattern that helps what TSNE really does. You cannot see that. TNS tries to build a 2D map where 2 points are close. They stay close in 2D. It does not preserve exact distances, axes, it preserves neighborhoods. And yes, distortion happens, but clusters are meaningful. Code sequence cluster together in TSNE, that means they are close in true 1280 D space. Which axes are sacrificed? All of them. Oh. A picture dimension 5. It builds a new artificial axis. They are optimized to keep neighbors together. They have no biological meaning. They are only for visualization. Why overlapping happens? Yes, two sequences might overlap in 2D, but be far in 1280. This is unavoidable. That's why it is used only for visualizing a cluster, not measuring distances. The key mental model. You built this, a coordinate system for DNA where distance not is somewhat equal to relatedness. Okay, okay. Okay. Okay, can you now brief the You built a protein similarity map using a large protein language model. Let me get some water. You used BioPython UniProt to download multiple versions of the same enzyme. Multiple version of the same enzyme. These came from different organisms, different strains, slightly different sequences, all do the same job, but their amino acid sequences are not identical. Interesting. History set a timer for 2 minutes. Okay. Stop getting distracted. You converted proteins into numbers using ESM2. You ran each amino acid sequence through. Okay, this model learned the grammar of proteins from hundreds of millions of sequences. For each protein, it produced 1280 dimensional vector that represents structure tendencies, functional motifs, evolutionary patterns. This vector is the protein's coordinate in protein space. You averaged token embeddings. ESM gives a vector for each amino acid in the protein. You average them so that one protein, one vector. That gives you 17 proteins, 17 vectors. Each vector is a compact mathematical fingerprint of the whole protein. Okay, I'm get. Average, okay. I would like more. If your protein has 320 amino acids, the module outputs. Each vector describes what an amino acid is doing in the context of whole protein. How? How do you? Secondary structure, bindings, motif, etc. These are token embeddings. So token embeddings is basically. So this is basically representing the physical slash chemical properties of the protein into a number that can be represented onto a why you cannot compare proteins yet. Two proteins do not have the same length. So you cannot do protein A because they have different number of vectors. You need one fixed representation per protein, okay? What averaging actually does. You took all residue vectors and did protein vector 1 by L residue vector. That means every amino acid votes equally on what the protein is. The result is a global fingerprint that captures fold tendencies, catalytic motifs, domain structure, evolutionary signals, because more patterns are present across many residues. Why averaging works biologically. The important features repeat across a protein. Helices span many residues. Active sites involve many residues. Domains are long. Important features repeat across a protein. Helices span many residues. Helices, okay. Active sites involves many residues. Domains are long, so when you average, noise cancels out. Real biological signals stay. This is why two proteins with similar structure function in similar averaged vectors, even if the sequences differ. What you created, you converted this protein to sequence, many residue vectors, one average vector, okay? Now proteins are comparable using geometry. This is why cosine similarity works. Intuition. Think of protein as a book. Each word as a vector. You average all word vectors. You got a vector representing the meaning of the whole book. That is exactly what you did for proteins. Okay. Yes, that is essentially correct, but it's more specific than just properties. Token embeddings is a numerical encoding of what one amino acid means in its biological context. Not just hydrophobicity, charge, size, but also whether it's in helix all at once. Okay, so if I want to see this, again, if I want to see how the embedding tokens, like what number is used for what, because like you said, I don't know what of the amino acid sequence is converted to tokens based on what it does. If I wanted to know, how can I? You cannot look up a table like lysine. That does not exist in ESM or NT transformer. The key thing is you're missing. Why are they no lookup table? The embedding is not amino acid properties. It is amino acid in the specific sequence. Meaning, example, same amino acid K, lysine in the enzyme active site on viral surface inside a membrane protein gets different vectors because meaning depends on context. That's exactly what same for amino acid. So can I know when thousands of biological signals, but still only statistically. You do things like compare the known active residue versus others, compare viral versus human proteins, compare conserved versus non-conserved. You already did one linear probing for virus class. This is literally is viral information encoded in these vectors. The answer is yes, accuracy 1. Bottom line, you did not get a table of codon numbers. But if I want to know what the embedding .py file did, can I though? Trons. But your exercise, yes, you can know exactly what your embedding script did, not what each. No, I want to know. But if I want to know, okay, let's say I want to know what should I do? Transformer forward pass. You must probe the space, not inspect it, not print it, not label it. You test it with biology. You pick a biological question. Well, I'm in the stream because I got the class in about 4 minutes. Peace out YouTube, peace out Twitch. We got a lot to learn. Oh boy, the more I read, the more stupid I get.